Hello, everyone. So we now have the ability to measure the energy available to your brain, and this tool could allow us to see why individuals with ME/CFS or Gulf War illness or long COVID or fibromyalgia, why they feel like they don't have the resources to do the things that they need to do. And so let me tell you what this scan is and what I'm going to do with it. So about a year ago, I did a video on adenosine triphosphate or ATP. And ATP in the brain is produced by mitochondria and it fuels all the cells and all the cellular processes. So it is fundamental to everything that happens in the brain. So if you don't have enough ATP for your brain, all your processes, cognitive, everything neural, everything glial, everything breaks down. So it's reasonable and a reasonable hypothesis that individuals with conditions like myalgic encephalomyelitis, chronic fatigue syndrome, or ME/CFS, have insufficient ATP. The mitochondria in this case aren't producing enough energy to support the demands, physical or mental or anything else. Now, how would we know if that hypothesis is correct? Well, we could measure ATP in the brain, and if it's deficient, that would give us the answer. But it's never been done. It's never been done in ME/CFS. It's never been done in fibromyalgia, not been done in long COVID, not been done in Gulf War illness. Why not? Well, it's because basically no one can do it. You can't use blood tests. You can't use peripheral tissue scans because the brain tightly controls its own energy production. So you can have a significant problem in the brain with ATP, but no measurable abnormalities in the body. So you can't do that. Now, of course, we have brain scanners, but normal MRI and PET scanner setups can't measure ATP. And that's because you have to measure phosphorus or phosphate. And that is the triphosphate part of ATP. It's these three phosphate groups. MRIs measure hydrogen, not phosphate. But there is a trick, which is having a really smart physics and engineering group custom build a phosphorus head coil, which we call a 31P head coil. And that would allow us to use magnetic resonance spectroscopy to detect and measure the ATP. And that's what we've been trying to do. Now, the good news is that we were awarded a grant that allows us to purchase this specialized equipment. And it's being made right now, and we should receive it in October of this year, which is 2026. Dr. Vinidra Mishram is the PI of that award. Now, since we now have the equipment coming in, I just need to get a grant that will cover the costs of recruiting participants, like people with ME/CFS, and healthy controls. And then we can see if the ATP is indeed suppressed in the disease. Now, I'm writing that grant proposal right now. Because this is a new idea, we'll start with a grant probably around the 200,000 US dollar amount. That's enough to get a good amount of preliminary data without throwing too many resources into an untested idea. It's what we call a pilot study. If the results look really good with the pilot study, we can then go for a larger grant to look at several different conditions. And if the approach is successful, it could be adopted by hospitals and in clinics worldwide. Now, we already have evidence that this approach is promising, and that's because a research group out of Germany very recently released a paper using this exact idea in post COVID neuropsychiatric conditions. The paper is still in press as of today, but it's open access, so you can already see it. And I put a link to that article in the video description. Now, they reported compelling evidence of deficient ATP in the cingulate cortex. And I'm showing you that right now. Now, there's weaker evidence for deficiencies in the posterior and anterior cingulate, but stronger evidence for ATP deficiencies in the mid cingulate, in this kind of middle part. Now, they do a lot of other analyses, and I'm not reviewing the paper in this talk. So for now, I'm just going to leave it at there's very interesting results of low ATP, especially in a region of the cingulate that is known to be critical for combining cognitive and emotion signals that drive effort and persistence. In other words, if your mid cingulate is not operating properly, it is almost impossible to do anything, even if there's nothing wrong with your peripheral body. So, especially now that we have data supporting the idea, this scan needs to be performed on all the chronic suspected neuroinflammatory and metabolic disorders that involve the brain. Now, why would your ATP for your brain be low? There are dozens of possibilities. I'll probably talk about those at another time, but a few major ones are chronic inflammation, chronic neuroinflammation, exposure to toxins, deficient nutrient intakes, especially like the B vitamins, and then there's genetic disorders in mitochondrial function. So that's mainly what I want to talk about. Just some really good news that we have this new, really important piece of equipment coming in, and there's a lot I'm going to be able to do with it. So that's the quick update. I'm really excited to get my hands on this coil. So I will definitely keep you up to date when we get some data from it. I'm really interested in combining it with the inflammatory scans that I talk about all the time because I think these measure very different things, but they're very much related. And I think we can get a more complete picture of the pathology when we combine ATP scanning with neuroinflammatory scanning. Now, I'll tell you when I'm awarded the grant, and I'll tell you when I start a project using the 31P head coil, just like with everything else. I always tell you when the study starts. It's unlikely that I'll tell you when and where I submit a grant proposal because I don't want to interfere with the grant review process. But whenever there's important updates, I'll definitely talk about them here. And that's it. I just wanted to tell you about that coil. The last thing, you can probably see that I'm still displaced from my office. I talked about that in the last video. I'm still stuck in this very boring room, but I did add one piece of artwork to try to help it. This is an original painting by Jane Kiskadon. She does an amazing job taking nature and fusing it with surreal and magical and whimsical themes. She's in Sonoma, California, which is a great place to be inspired to create this kind of art. Okay, so anyway, to end this, next time, probably in 2 weeks, I plan to tell you about a newly awarded clinical trial that I'm involved in that will be testing cutting edge photobiomodulation devices. And you're definitely going to want to hear all about that one. All right, so for now, I'm going to get back to grant writing and I will be back soon.